Think about this for a second. Everything you've ever learned about prehistoric times, those shadowy stretches of history before written records, might be completely wrong. The past isn't just set in stone. It's constantly being rewritten by the unrelenting march of science. And right now, we're living through a golden age of discovery, where every year, researchers peel back another layer of the ancient world, revealing truths so startling they force us to rethink what it means to be human. From long-lost civilizations to mind-bending artifacts that defy explanation, the story of our origins is far more mysterious and far more thrilling than we ever imagined. What if I told you that some of the most fundamental truths about early humans, how they lived, what they believed, even how they shaped the world around them, are being overturned right before our eyes? Picture this: deep in a remote cave, a team of archaeologists brushes away centuries of dust to uncover a tool so advanced it shouldn't exist for another 10,000 years. Or consider the haunting traces of a forgotten culture, its monuments hidden beneath layers of earth, waiting to shatter the timelines we've clung to for generations. These aren't just isolated curiosities, they're seismic shifts in our understanding, each one rewriting the textbooks and forcing us to ask, how much do we really know about the dawn of humanity? That's exactly what we're diving into today: 30 of the most jaw-dropping breakthroughs in prehistoric science, discoveries that are turning history on its head. We'll journey from the depths of ancient oceans to the tops of mountains that once teemed with life, uncovering clues that challenge everything we thought we knew. Some of these revelations will make you question the very fabric of time, while others will leave you in awe of the ingenuity of our ancestors. So buckle up, you're about to witness a side of prehistory that's wilder, more unpredictable, and more exhilarating than anything you've heard before. The past is calling, and it's got one heck of a story to tell. Let's start with a discovery so groundbreaking it rewrote the entire timeline of human innovation: the Lomqui stone tools. Buried in the dusty plains of Kenya, these ancient artifacts date back a staggering 3.3 million years, a full 700,000 years older than the earliest known tools attributed to Homo habilis, the so-called handyman. That's not just a small adjustment to history, it's a complete upheaval. For decades, scientists believed tool-making was synonymous with our genus, Homo, a defining trait that set us apart. But the Lomqui tools shattered that assumption, proving our ancestors were crafting implements long before Homo even existed. So what do these tools look like? Picture rough, heavy rocks with deliberate flaking, not the refined blades of later eras, but unmistakably shaped by intention. They were likely used for cracking nuts, butchering meat, or processing plants, a glimpse into the daily struggles of a species we're only beginning to understand. What's truly mind-blowing is who made them. The leading theory points to Australopithecus, a small-brained, bipedal ancestor more closely related to Lucy than to modern humans. That means intelligence and adaptability, traits we once thought were uniquely ours, were brewing much earlier in the evolutionary tree. This discovery forces us to rethink not just when tool-making began, but why. Was it driven by climate change, pushing early hominins to innovate in a shifting landscape? Or was it a gradual process, trial and error over millennia? Either way, the Lomqui tools are a humbling reminder. The story of human ingenuity is far older and far more complex than we ever imagined. And this is just the first chapter. Wait until you see what else we've uncovered. Just when we thought the human family tree couldn't get any stranger, along came a discovery that left scientists scratching their heads: the tiny, mysterious inhabitants of Flores Island. In 2003, deep inside the limestone caves of Indonesia, researchers unearthed bones so peculiar they seemed ripped straight from folklore. These weren't the remains of modern humans or even our well-known Neanderthal cousins. No, these belonged to a group of individuals barely 3 feet tall, with brains smaller than a chimpanzee's, yet evidence suggests they crafted stone tools and hunted stegodonts, a now extinct relative of elephants. Meet Homo floresiensis, nicknamed the Hobbit for its diminutive stature, a species that rewrote the rulebook on human diversity. The initial reaction to these fossils was a mix of awe and skepticism. How could such small-brained hominins perform complex behaviors like tool-making? Some scientists argued these were merely modern humans suffering from microcephaly or other genetic disorders, but the sheer number of similar skeletons along with their distinct anatomical features painted a different picture. Their wrists were primitive, resembling those of early hominins like Australopithecus, and their feet were unusually long, better suited for climbing than walking. This wasn't a diseased population, it was a relic of an ancient lineage thriving in isolation long after other early humans had vanished. What makes this discovery even more extraordinary is the context. Flores Island was a place of extremes, home to giant rats and Komodo dragons, a real-life land of giants and miniature creatures. Homo floresiensis likely arrived on the island nearly 1 million years ago, possibly descending from Homo erectus. Over millennia, they underwent a remarkable evolutionary process called island dwarfism, shrinking in size to adapt to limited resources. But here's the twist: evidence suggests they survived until as recently as 50,000 years ago, meaning they may have crossed paths with our own species. Imagine the encounters: towering Homo sapiens meeting these tiny, resourceful people, their cultures colliding in ways we can only guess at. The debate over the hobbit's place in our family tree is far from settled. Some researchers propose they're a dwarfed offshoot of Homo erectus, while others argue for an even older ancestor, a ghost lineage we've yet to uncover. What's undeniable is how this discovery humbles us. It forces us to confront how little we truly know about the twists and turns of human evolution, and how many surprises might still lie buried, waiting to shake the foundations of science. And if a 3-foot-tall species with stone tools can upend our assumptions, what else is out there? For decades, Neanderthals were painted as our brutish, cave-dwelling cousins, doomed to extinction because they couldn't compete with the brilliance of Homo sapiens. Then, in 2010, a scientific bombshell dropped that shattered this arrogant narrative. Geneticists successfully sequenced the Neanderthal genome using DNA extracted from bones dating back 40,000 years, and what they found rewrote the story of human evolution. Hidden in the genetic code of modern humans outside Africa was undeniable proof: 1 to 4% Neanderthal DNA. Not only had our ancestors encountered Neanderthals, they'd had children with them. This revelation upended everything. Suddenly, Neanderthals weren't evolutionary dead ends. They were our relatives woven into the fabric of who we are today. The implications stretched far beyond genetics. By tracing where these shared DNA segments appear in modern populations, scientists could map ancient migration routes with startling precision. The highest concentrations appear in people of European and Asian descent, suggesting interbreeding occurred somewhere in the Middle East between 50 and 60,000 years ago, as early Homo sapiens ventured out of Africa. But here's the twist: those Neanderthal genes aren't distributed evenly. Some, like genes linked to immune system function, appear in many populations, hinting they provided a survival advantage. Others, like genes influencing skin and hair traits, cluster in specific regions, suggesting adaptation to local environments. Yet the most fascinating part isn't just that we mixed, it's how that mixing shaped us. Neanderthal DNA contributes to everything from our immune response to our risk for certain diseases. Some studies even suggest their genes influenced our skin's ability to withstand colder climates, giving migrating humans a critical edge. But it wasn't all beneficial. Certain Neanderthal gene variants, like those linked to blood clotting or depression, might have been harmful in new environments, explaining why natural selection pruned them over time. What's truly humbling is realizing this genetic handshake wasn't a one-time event. multiple waves of interbreeding likely occurred across thousands of years, creating a complex mosaic of ancestry. And Neanderthals weren't the only ancient humans we mingled with. Discoveries like the Denisovans reveal our family tree was more of a tangled web, with branches crossing in ways we're still unraveling. So the next time you look in the mirror, remember, you're not just Homo sapiens, you're part of a far richer, messier legacy, one written in bones, migration routes, and the echoes of encounters lost to time. Deep in the frozen heart of Siberia's Altai Mountains, a cave once sheltering ancient humans gave up one of the most astonishing secrets in paleoanthropology, and it all started with a single fragment of bone. In 2008, Russian archaeologists sifting through Denisova Cave unearthed a tiny pinky bone, no bigger than a pencil eraser. At first glance, it seemed unremarkable, just another fossil in a region rich with Neanderthal remains. But when scientists extracted its DNA 2 years later, the results sent shockwaves through the scientific community. This wasn't Neanderthal, it wasn't Homo sapiens. It was something entirely new, a previously unknown human species we now call the Denisovans. What makes this discovery so extraordinary isn't just the identification of a new branch on our family tree, but how much we've learned from so little. That single finger bone held enough genetic material to reconstruct an entire genome, revealing a population that diverged from Neanderthals around 400,000 years ago. Unlike their Western-dwelling cousins, Denisovans spread across Asia, adapting to environments from steppes to rainforests. But here's where it gets even wilder: their DNA didn't vanish with them. Traces of Denisovan ancestry live on today, woven into the genes of modern Melanesians, Aboriginal Australians, and certain Southeast Asian groups at levels as high as 5%. Some of their genetic gifts are startlingly specific. Take the EPAS1 gene, a variant found in Tibetans that helps their blood thrive in thin, high-altitude air. Scientists traced this adaptation directly back to Denisovan interbreeding, a life-saving legacy from a species we didn't even know existed 15 years ago. Other fragments of their DNA appear to influence immune responses, fat metabolism, even the shape of teeth, proof that our encounters with them weren't just fleeting moments, but exchanges that reshaped human biology. Yet for all we've pieced together, the Denisovans remain shrouded in mystery. No full skulls have been found, leaving their appearance to speculation. A jawbone discovered in a Tibetan cave 200 meters above sea level hints at their rugged adaptability, while a three-dimensional reconstruction of that original pinky bone suggests they had unusually slender digits. The real shocker: in 2018, geneticists identified a fossil from Denisova Cave as the hybrid daughter of a Neanderthal mother and Denisovan father, the first direct evidence of interbreeding between two distinct ancient human groups. This raises spine-tingling questions. How many other lost lineages might be hiding in our DNA? Why did Denisovans vanish while leaving such indelible marks on us? Every answer pulls us deeper into the tangled saga of human evolution, a story where we're not the sole protagonists, but the inheritors of a world far stranger and far more interconnected than we ever dreamed. And somewhere out there, in caves not yet explored or sediments still unexamined, more chapters of that story are waiting to rewrite history all over again. One of the most startling discoveries in prehistoric medicine isn't some primitive herbal remedy, it's proof that ancient humans performed complex brain surgery with remarkable success. Imagine a world without anesthesia, without sterilization, yet somehow healers or shamans were carefully drilling or scraping holes into living skulls, and their patients walked away alive. This practice, called trepanation, dates back at least 7,000 years, with archaeological evidence spanning from Peru to France, Siberia to Africa. The most jaw-dropping part: many of these patients survived, their skulls showing clear signs of healing, bone regrowth smoothing the edges of those man-made openings. Let's put this into perspective. the oldest known trap and skull comes from a Neolithic burial in France dating back around 6,500 years. But the practice wasn't isolated, it was widespread. In South America, the Inca perfected trepanation to an astonishing degree, with survival rates estimated at up to 80% based on skeletal remains. Some patients even underwent multiple procedures, their skulls peppered with overlapping holes, each one a testament to their resilience. How did these ancient surgeons achieve such precision? Tools varied from obsidian blades to hand-cranked drills, but the real mystery lies in their knowledge. Did they understand infections well enough to clean wounds, or was survival partly luck? The bigger question, though, is why. Evidence points to two possible motives: medicine and ritual. Some skulls show fractures or signs of disease beneath the openings, suggesting trepanation may have relieved swelling or pressure from head injuries. Others, however, lack visible trauma, hinting at symbolic purposes. In cultures worldwide, the skull was seen as a vessel for spirits or evil forces, and creating an opening might have been an attempt to release pain, cure madness, or even commune with the divine. The fact that trepan skulls are often found in ceremonial burials supports this theory. What's truly humbling is realizing these procedures weren't rare experiments, they were refined over millennia. Inca surgeons, for example, evolved their techniques, shifting from crude scraping to precise circular cuts that minimized damage. Some even used metal plates or gourds to protect the exposed brain post-surgery. And it wasn't just adults. Children as young as 10 underwent trepanation, their small skulls bearing the same telltale marks. This raises a profound question: how much medical knowledge has been lost to time? These ancient practitioners had no microscopes, no textbooks, yet they grasped enough about anatomy and healing to perform risky surgeries with shocking success rates. Next to this, even modern medicine pauses in respect. So the next time someone calls prehistoric cultures primitive, remember, they were cracking open skulls and saving lives thousands of years before we mapped the human genome. The moment early humans picked up ochre or charcoal to leave their first deliberate marks on a cave wall, something extraordinary happened. They stopped merely surviving and began creating. For decades, Europe's El Castillo cave in Spain held the crown for the world's oldest known art, with its eerie red hand stencils dating back around 40,000 years. But in 2014, a discovery in Indonesia shattered that record. Deep in the limestone caves of Sulawesi, researchers found a life-sized painting of a babirusa, a pig deer native to the region, created at least 45,500 years ago. Suddenly, the timeline of human creativity had to be redrawn, and the debate over where art truly began ignited with fresh intensity. What makes these two sites so mesmerizing isn't just their age, it's the stark contrast in style and purpose. The hand stencils of El Castillo, created by blowing pigment around a pressed palm, feel deeply personal, almost like signatures reaching across millennia. Some scholars argue these weren't just decorations but ritual acts, a way to claim space or connect with the spiritual world. Meanwhile, the Sulawesi painting is a detailed, naturalistic depiction of an animal, complete with shading and anatomical precision. This wasn't a symbolic mark, it was a narrative, a story frozen in time. The difference raises a tantalizing question. Did art emerge independently across the globe, or did it spread with migrating human populations, adapting to new environments and cultures? The Sulawesi discovery carries another bombshell location. For generations, the prevailing theory held that Europe was the cradle of artistic innovation, fueled by the so-called creative explosion of early Homo sapiens. But Indonesia's cave art predates Europe's by thousands of years, suggesting that the urge to create wasn't tied to one region or population. It was a universal human trait bubbling up wherever our ancestors roamed. Even more astonishing, the Sulawesi paintings were made in a challenging environment, humid tropics where preservation is rare. The fact that they survived at all hints at untold artistic traditions lost to time, their canvases crumbled by climate or swallowed by rising seas. Yet El Castillo's handprints hold their own mysteries. Recent studies suggest some might be the work of Neanderthals, not Homo sapiens. If true, this rewrites another chapter of history, the assumption that symbolic thought was uniquely human. Imagine the implications: a parallel artistic tradition, a lost gallery of Neanderthal expression waiting to be found. The debate between these two sites isn't just about dates, it's about what art means. Is it the birth of storytelling as seen in Sulawesi's detailed fauna, or is it the primal need to say, "I was here," as echoed in El Castillo's ghostly hands? The answer might lie in the caves themselves. Sulawesi's art often appears in narrow, hard-to-reach chambers, suggesting these spaces were special, perhaps reserved for ceremonies or initiations. El Castillo's stencils, meanwhile, cluster near entrances visible to all. One culture turned caves into private galleries, the other into communal billboards. This dichotomy reveals something profound. Art wasn't just a single breakthrough. It was a kaleidoscope of human impulse, reflecting everything from survival to spirituality. As dating techniques improve, older artworks may emerge, pushing the origins of creativity even further back. But for now, these two sites stand as bookends to a revolution. The moment our ancestors looked at a blank wall and saw not just rock but a canvas. And in their pigments and palm prints, we find the earliest echoes of a question that still drives us today. What does it mean to be human? For thousands of years, historians believed civilization followed a straightforward path. First came agriculture, then permanent settlements, and finally, with surplus resources, humans built grand monuments. That tidy timeline collapsed overnight when a German archaeologist brushed away the dirt from a Turkish hillside in the 1990s, revealing something impossible. Göbekli Tepe, a sprawling complex of massive stone pillars carved with intricate animal reliefs, wasn't built by farmers in a thriving city. It predated agriculture by thousands of years, dating back an astonishing 11,600 years to a time when humans were still nomadic hunter-gatherers. The scale of Göbekli Tepe defies logic. Its circular enclosures house towering limestone pillars weighing up to 20 tons, some standing 5 meters tall. The craftsmanship is breathtaking. Snakes coil around the edges, foxes leap in mid-motion, vultures spread their wings with anatomical precision. These weren't crude markings, they were masterpieces carved by people with sophisticated symbolic thought. But here's the radical implication. Hunter-gatherers supposedly lacked the organization, resources, or need for such projects. Yet at Göbekli Tepe, they quarried, transported, and erected stones so heavy it would take dozens of people working in unison, a level of coordination that rewrites our understanding of pre-agricultural societies. What drove them to build it? The leading theory is as profound as it is controversial: religion. Unlike later temples tied to cities, Göbekli Tepe stands alone, a ritual center drawing scattered groups from across the region. The carvings, dominated by predators and death symbols like scorpions and headless humans, suggest a spiritual focus on the dangerous forces of nature. Some researchers propose it was a site for funeral rites or initiation ceremonies, where communities gathered seasonally to worship, feast on wild game, and carve their myths into stone. This flips the script on civilization's origins. Instead of agriculture enabling religion, perhaps the need to gather for rituals sparked agriculture, as feasting demands led to deliberate cultivation of wild grains found nearby. The site's abandonment deepens the mystery. After 1,500 years of use, Göbekli Tepe was deliberately buried, each enclosure carefully filled with rubble. Was it a ritual act, a way to retire sacred space, or did the social changes it helped catalyze, like early farming, render it obsolete? What's undeniable is its legacy. Like a stone thrown into a pond, the ripple effects of this temple may have altered human history. The very grains first cultivated near Göbekli Tepe einkorn wheat, for instance, became staples of the agricultural revolution. Its builders didn't just carve pillars, they might have carved the path to civilization itself, proving sometimes the deepest truths lie not in what we expect to find, but in what shakes our assumptions to the core. And here's the tantalizing thought. If Göbekli Tepe was this advanced, what other monumental sites from our nomadic past remain hidden, waiting to rewrite history again? The discovery of stone tools alongside Homo floresiensis remains didn't just rewrite the story of this tiny species, it demolished one of anthropology's most stubborn assumptions, that big brains equal advanced technology. Buried in Liangbua Cave, the same site where the hobbits' bones were unearthed, archaeologists found an array of meticulously crafted stone flakes, points, and cutting tools. At first glance, they resembled the typical toolkit of early humans: sharp edges, purposeful design. But here's the catch. These artifacts date to between 50,000 and 100,000 years ago, a period when Homo floresiensis was the island's sole resident. And their brains 1/3 the size of ours. What makes these tools so baffling isn't just their sophistication, it's the gap between anatomy and ability. For decades, scientists tied complex toolmaking directly to brain volume, arguing that larger prefrontal cortices allowed for forward planning and fine motor control. Yet the hobbits' tools, some no bigger than a thumbnail, required precise strikes to shape volcanic rock into razor-edged implements. Some even show signs of hafting, being attached to wooden handles, a technique once thought beyond small-brained hominins. Imagine a species with cognitive capacities closer to chimpanzees producing tools on par with those made by Homo erectus, a relative with 3 times their brain power. It's like finding a pocket calculator built by a society that never discovered electricity. The implications ripple far beyond Flores. If a hominin with a grapefruit-sized brain could master these skills, what does that say about intelligence itself? Perhaps neural organization mattered more than sheer volume, with densely packed neurons or specialized brain regions enabling complex behavior. Or maybe prolonged cultural transmission, generations patiently teaching the next could compensate for cognitive limits. Tools from the cave hint at this. Their consistent styles suggest standardized methods passed down over millennia, a cultural legacy strong enough to endure despite biological constraints. Then there's the mystery of their raw materials. Unlike mainland toolmakers who often traveled miles to quarry the finest stone, hobbits worked with what they had: local volcanic rock, brittle and prone to shattering. Yet they adapted, developing techniques to exploit its properties. Some tools even bear wear patterns indicating they processed tough plants or butchered Komodo dragons, proving these weren't theoretical skills but vital survival technologies. This forces us to confront an uncomfortable truth. Our benchmarks for intelligence might be hopelessly biased. We've long measured ancient minds by how closely they resembled ours, dismissing small-brained species as dead-end failures. But Homo floresiensis thrived in isolation for hundreds of thousands of years, crafting tools that defied their anatomy and hunting prey that could kill them. Their story isn't one of limitation, it's a testament to evolution's creativity, proving that in the right circumstances, even the smallest brains could engineer solutions that leave us humbled. And if that's possible, how many other impossible feats might lie hidden in the fossil record, waiting to challenge our arrogance? For generations, the story of the first Americans seemed neatly wrapped in a boa. Around 13,000 years ago, a culture known as the Clovis people crossed the Bering Land Bridge from Siberia, wielding distinctive spear points to hunt mammoths as they spread south. That tidy narrative unraveled spectacularly in the 1970s when archaeologists in southern Chile uncovered a site called Monte Verde, a waterlogged time capsule preserving something extraordinary: unmistakable human footprints, tent structures, even chewed seaweed, all dating back at least 14,500 years. Suddenly, the timeline of human arrival in the Americas had to be pushed back over 1,000 years, and the entire Clovis first model was thrown into doubt. Monte Verde isn't just old, it's impossibly well preserved. Unlike most prehistoric sites where only stone tools survive, this peat bog environment kept organic materials intact. Imagine walking into a campsite frozen in time. Wooden stakes still lashed together with fiber ropes, hearths lined with clay, remnants of medicinal plants like mastodon bones with cut marks. Proof these weren't just passers-by, but settlers who knew how to exploit local resources. The real kicker, Monte Verde lies 8,000 miles south of the Bering Strait, meaning humans didn't just arrive earlier than we thought, they migrated south at breakneck speed, reaching Chile practically as glaciers still gripped the north. This raises a staggering question. How did they get there so fast? The leading theory now points to coastal migration. During the last ice age, lower sea levels exposed a highway of ice-free corridors along the Pacific coast, rich with kelp forests that sustained marine life and possibly humans in skin boats. Instead of trudging inland through icy valleys, early Americans might have island hopped from Beringia down to warmer latitudes within generations. Supporting this idea are sites like Cooper's Ferry in Idaho, where artifacts date back 16,000 years, and the Channel Islands off California, where 15,000-year-old tools suggest seafaring skills far beyond what we credited Ice Age humans with. But the real bombshell came in 2021, when fossilized human footprints in New Mexico's White Sands National Park were dated to an astonishing 23,000 years ago, nearly 10,000 years before Clovis. These prints, left by teenagers and children splashing through ancient wetlands, prove humans thrived in North America during the height of the last ice age, a time when glaciers should have made continental crossings impassable. Either our ancestors arrived much earlier than anyone imagined, weathering millennia of harsh conditions, or they found routes we've yet to map, perhaps even crossing the Pacific by boat from Asia, a theory gaining traction with each new discovery. The implications were right not just when humans reached the Americas, but who they were. Genetic studies of modern indigenous groups revealed traces of an ancient population dubbed Population Y, distantly related to Australasians, hinting at multiple waves of migration from different origins. Some tools at pre-Clovis sites, like the bifacial blades at Texas's Galt site, resemble those from Siberia's Ushki Lake, suggesting diverse toolkits arrived with distinct groups. It's a far cry from the old image of a single Clovis vanguard instead. The first Americans were likely a mosaic of peoples arriving at different times by different paths, each adding threads to the tapestry of indigenous ancestry. What's humbling is realizing how much we still don't know. Every pre-Clovis site unearthed chips away at old certainties, revealing a continent explored not in one triumphant march, but in fits and starts by resourceful pioneers whose stories are only now emerging from the earth. And if 23,000-year-old footprints can append textbooks overnight, what other surprises lie buried, waiting to shake our understanding of humanity's greatest journey? The first Americans didn't just cross a land bridge, they sailed, trekked, and adapted in ways we're only beginning to fathom, turning the New World's oldest chapter into one of history's most thrilling mysteries. In the dusty hills of South Africa's Tong region, a limestone quarry worker handed a peculiar rock to anatomist Raymond Dart in 1924, a discovery that would ignite one of the fiercest debates in paleoanthropology. Nestled inside that rock was the partial skull of a young hominin, later named the Tong Child, a 2.8-million-year-old specimen of Australopithecus africanus. For decades, scientists focused on its small brain case, dismissing it as a primitive ancestor with limited intelligence. But then, cutting-edge scanning technology revealed something astonishing. Hidden within that tiny skull was a brain organized startlingly like our own. Advanced synchrotron imaging, a technique far more precise than traditional X-rays, allowed researchers to map the Taung child's endocast, a natural imprint of the brain's surface left on the inner skull. What they found turned assumptions upside down. The frontal lobes responsible for complex decision-making in modern humans showed remarkable development. Even more surprising were the grooves and folds in the parietal lobes, areas linked to tool use and spatial reasoning. These weren't the neural wirings of a simple ape-like creature. They hinted at cognitive potential we once thought emerged much later in Homo species. But the real bombshell lay in the lunate sulcus, a groove that separates visual processing areas from the rest of the brain. In chimpanzees, it's positioned far forward, prioritizing sight over higher thought. In humans, it's recessed, making room for advanced cognition. The Taung child's lunate sulcus, much closer to ours. This suggests that even before brain size ballooned in our Homo ancestors, the neural architecture for human-like thinking was already taking shape. Imagine that a child who died nearly 3 million years ago might have processed the world in ways startlingly similar to how we do. Critics initially argued these features could be artifacts of preservation or growth patterns in a juvenile. But when scans of other Australopithecus fossils matched the Taung child's neural patterns, the evidence became undeniable. This wasn't a fluke, it was a trend. These early hominins weren't just stumbling toward humanity, they were already laying the mental groundwork for everything that followed. Perhaps they wielded tools we've yet to find, or communicated in ways leaving no fossil trace. Either way, their brains were rewiring for a future no one could have predicted. The Taung child's legacy isn't just in challenging timelines, it's in redefining intelligence itself. Big brains might have given Homo sapiens an edge, but the blueprint for complex thought was drafted millions of years earlier, in species we've long underestimated. So the next time someone calls Australopithecus just an ape, remember, inside that small skull burn the first sparks of what would one day become the human mind. And if that's true, what other cognitive revolutions are we missing, hidden in the silent fossils of our deepest past? For a man who died violently over 5,000 years ago, Ötzi the Iceman has an astonishing ability to make headlines. Discovered in 1991 by hikers in the Italian Alps, this incredibly preserved mummy has offered scientists a window into the Copper Age unlike any other. But perhaps no discovery about him is more intimate than what he ate just before his death. When researchers finally analyzed Ötzi's stomach contents in 2018, they didn't just find a meal, they uncovered a snapshot of survival, a desperate final act that rewrote what we thought we knew about ancient diets. The contents read like a recipe for endurance. His last supper was a fatty, high-calorie mix of ibex meat, red deer, and einkorn wheat, along with traces of toxic fern, likely not food but a wrapping to preserve the meat. The sheer diversity is striking. Here was a man crossing mountainous terrain, yet his meal combined hunted game with cultivated grains, proving that even 5,300 years ago, humans balanced foraging and farming. But the real revelation was the fat content. Ötzi's stomach held nearly 50% fat by volume, an intentional choice for someone needing long-lasting energy in freezing conditions. Modern athletes wouldn't consume that ratio unless preparing for an ultramarathon, yet Ötzi's people clearly understood nutrition's role in stamina. Then there's the pollen. Mixed into his meal were traces of hop hornbeam tree pollen, pinpointing his final hours to late spring or early summer. Even more telling, the pollen wasn't digested, meaning he inhaled it shortly before death, likely during a frantic climb. Combined with undigested muscle fibers from his meat, scientists could reconstruct his last day. A hunted man, exhausted but fueled by a strategic meal, fleeing upward until an arrow struck his shoulder. The fern toxins in his stomach add another layer. Were they medicinal, or did desperation drive him to eat spoiled rations? This isn't just about one meal, it's a paradigm shift. Before Ötzi, we assumed prehistoric diets were monotonous, tied rigidly to local resources. Yet here was evidence of complex food processing, seasonal planning, and macro-level understanding of nutrients. The einkorn wheat alone suggests trade networks or travel. It couldn't grow at the altitudes where he died, and the ibex meat charred from cooking shows deliberate preparation to maximize calorie retention. What's haunting is how humanizing this snapshot is. Ötzi wasn't a caveman gnawing raw meat. He was a man with knowledge preparing carefully for danger. His last meal is a testament to ingenuity, a reminder that the past isn't a crude prelude to modernity, but a mosaic of sophistication we're only beginning to decode. And if one stomach can reveal this much, imagine the stories still frozen in time, waiting to be tasted. The story of humanity's love affair with wine just got a whole lot older, and it starts in a place most people wouldn't expect. Nestled in the foothills of the South Caucasus, in what's now modern-day Georgia, archaeologists unearthed 8,000-year-old clay jars stained with something extraordinary, the chemical fingerprints of wine. These aren't just the oldest traces of fermented grapes ever found, they rewrite the history of viticulture, proving humans were mastering the art of winemaking a staggering 600 to 1,000 years earlier than we ever imagined. What makes these residues so definitive? Scientists used advanced chromatography to identify tartaric acid, a compound that screams wine when found in ancient vessels alongside malic and succinic acids, all telltale byproducts of fermentation. But here's the twist, these jars weren't stored in some royal cellar. They were buried in the floors of simple mud brick homes, their interiors coated with beeswax to seal in the liquid. This wasn't a luxury for elites, it was everyday life, a staple woven into the fabric of these early farming communities. The implications ripple far beyond a tipsy revelation. Before this discovery, the earliest evidence came from Iran's Zagros Mountains, dating to around 5,400 BC. Georgia's jars, clocking in at 6,000 BC, shift the cradle of winemaking northward, suggesting the South Caucasus wasn't just an agricultural hub, it was an innovation lab where humans transformed wild vines into cultural cornerstones. And those vines weren't random. DNA analysis links them to modern Georgian grape varieties, proving these early vintners weren't just fermenting whatever grew nearby. They were selectively cultivating, refining, and passing down knowledge across generations. Why does this matter? Because wine wasn't just a drink, it was a revolution. Unlike grain, which could be stored dry, grapes demanded rapid processing, pushing communities to develop new technologies like airtight ceramics. The social impact was equally profound. Shared drinking rituals likely strengthened bonds, sealed alliances, or played roles in spiritual practices. Some researchers even argue that wine's allure might have incentivized permanent settlements, anchoring people to tend vines year-round. But the real marvel is how little the basics have changed. Those ancient Georgians used cuve, every large, egg-shaped clay vessels buried underground, to ferment wine, a method still practiced in the region today. The same earthy, tannic profiles modern winemakers chase. Their ancestors were crafting it millennia ago without thermometers or chemistry guides, just intuition honed through trial and error. So raise a glass not just to the world's oldest wine, but to the unknown innovators who looked at a wild grape and saw potential. In their hands, fruit became something transcendent, a drink that would shape trade, religion, and culture across continents. And if they were this advanced 8,000 years ago, what other forgotten flavors of history are waiting to be uncorked? One of the most astonishing medical breakthroughs from the ancient world isn't a surgical technique or herbal remedy, it's a simple wooden toe. In the early 2000s, archaeologists examining a 3,000-year-old Egyptian mummy noticed something extraordinary. Her left foot bore a meticulously carved wooden toe, complete with a hinge and strap marks that suggested it wasn't just for show. Where patterns on the sole showed it had been used extensively, making this the oldest known functional prosthetic in the world, a revelation that rewrites the history of medical innovation. What makes this discovery so groundbreaking isn't just its age, it's the sophistication behind it. The toe, crafted from a durable wood like sycamore or acacia, wasn't a crude peg. It followed the natural contours of the foot, with subtle grooves where the remaining toes would have rested, ensuring balance and comfort. The hinged joint at the base allowed for flexibility, mimicking the movement of a real toe. But the real clincher, the straps weren't just decorative, their placement aligned with pressure points from walking, proving this wasn't a burial accessory. This woman lived with her prosthetic, relying on it daily to navigate uneven terrain, climb steps, or even dance. The implications are staggering. For centuries, we assumed prosthetics were a relatively modern invention, with the earliest references pointing to Roman-era iron hands or Renaissance peg legs. But this toe pushes the timeline back over a millennium, revealing an ancient society with a deep understanding of biomechanics and patient care. The craftsmanship suggests specialized artisans were carving custom prosthetics long before Hippocrates laid the foundations of Western medicine. Even more remarkable is the social insight. The woman who wore it lived during the New Kingdom, a period when amputations were often linked to diabetes or trauma. The fact that she received such a sophisticated device hints at a culture that valued mobility and dignity, even for those with disabilities. Modern testing adds another layer of wonder. When researchers created replicas and had volunteers walk with them, the results were astonishing. The design distributed weight so effectively it rivaled some contemporary prosthetics. The toe's curvature even accounted for the absence of modern cushioning, using natural materials to absorb shock. This wasn't trial and error, it was engineering. But the biggest question remains unanswered: how many others like it existed? Organic materials rarely survive millennia, making this toe a rare time capsule. If Egyptians were crafting functional prosthetics 3,000 years ago, what other medical marvels have been lost to decay? This single wooden digit forces us to reconsider the limits of ancient innovation and reminds us that the drive to restore, adapt, and overcome is as old as humanity itself. The peaceful hunter-gatherer image of early humans shatters at a lonely cemetery along the Nile, where the bones tell a story written in violence. Jebel Sahaba, a burial site in what's now northern Sudan, holds the grim distinction of being the oldest known battlefield, a 13,000-year-old graveyard where nearly half the bodies bear marks of brutal, purposeful killing. Arrowheads lodged in bones, skulls crushed by blunt force, forearms fractured in defensive wounds. This isn't random conflict. It's the smoking gun of humanity's first known war, proving organized violence predates agriculture, cities, or even permanent settlements by millennia. What makes Jebel Sahaba so haunting isn't just the scale of violence, but its chilling predictability. Of the 61 skeletons excavated, at least 27 show clear signs of violent death, with many more likely lost to time. The victims weren't warriors in any modern sense. Men, women, and children alike fell to flint-tipped projectiles, their injuries clustering around the head and torso. Some bodies were found with multiple wounds, suggesting they were attacked repeatedly, even after death. But here's the twist: these weren't crude close-quarter brawls. The arrowheads, all crafted from a distinct type of chert not local to the area, point to planned ambushes by outside groups wielding standardized weapons. This was warfare with tactics, not spontaneous skirmishes. The context of this bloodshed rewrites assumptions about what drives human conflict. Jebel Sahaba dates to the tail end of the last ice age, a time when the Nile Valley was a parched, hyper-competitive landscape. Shifting climates had compressed rival groups along the river's dwindling resources, turning fertile corridors into tinderboxes. Analysis of the victims' teeth reveals periods of severe malnutrition, stress fractures in the enamel-matching years of drought. Starvation, it seems, was the real weapon. The arrows were just its delivery system. Yet the most disturbing insight comes from how these people were buried. Unlike later war graves, where victors might ritualistically arrange the dead, Jebel Sahaba skeletons were haphazardly piled, some with projectile points still embedded in their bones. There's no evidence of care in their interment, suggesting survivors were too traumatized or outnumbered to properly mourn. Even more telling, many skeletons show healed fractures from older attacks. This wasn't one tragic battle, it was generations of cyclical violence, a centuries-long stalemate of raids and reprisals that finally culminated in massacre. Modern parallels are unavoidable. The same environmental pressures that fueled Jebel Sahaba climate shifts, resource scarcity, territorial disputes still drive conflicts today. But what's truly humbling is realizing this cemetery isn't an anomaly. Recent reanalysis using CT scans uncovered previously overlooked microfractures and spear impacts, hinting that prehistoric violence was far more widespread than we once believed. If war could erupt among nomadic bands with no wealth or borders to fight over, how deep does this instinct run? The answer might lie in the Nile's silent graves, where the first war dead whisper a warning across 13,000 years. Given the right conditions, humans will always find reasons to turn on each other. And if that's true, what does that say about us? We've always imagined dog domestication as a neat turning point. Somewhere around 15,000 years ago, a bold wolf crept closer to a human campfire and history was made. But genetics has a way of upending our tidy stories, and the latest research reveals a far messier, more fascinating timeline. Cutting-edge DNA studies now suggest dogs diverged from wolves not once, but possibly multiple times across Eurasia, with the earliest splits occurring as far back as 40,000 years ago, nearly double the age we once believed. That's not just a tweak to history, it's a complete rewrite of humanity's first friendship. The evidence comes from ancient wolf and dog bones analyzed with precision we couldn't have dreamed of a decade ago. When scientists sequenced DNA from a 35,000-year-old Siberian wolf bone, they found genetic signatures strikingly similar to modern dogs, hinting that the split between wolves and proto-dogs was already underway. Even more compelling are the remains of a 40,000-year-old canid from Belgium, whose DNA sits right at the evolutionary crossroads. This wasn't a full-fledged dog, but it wasn't purely wolf either. It's as if we're catching domestication in its earliest whispers, a slow dance of mutual curiosity that spanned millennia. But here's the twist: this wasn't a single event centered in one region. Genetic diversity in ancient dog remains points to at least two, possibly three, separate domestication hotspots, one in Europe, another in East Asia, and perhaps even a third in the Middle East. Picture this: different groups of wolves drawn to different human camps for different reasons, some scavenging leftovers, others aiding in hunts, each forging their own bond with people. Over time, these lineages mixed, migrated, and reshaped one another, creating the patchwork ancestry we see in dogs today. Why does this matter? Because it reshapes how we see early human societies. If dogs were by our side 40,000 years ago, they weren't just pets, they were partners during some of our most vulnerable chapters. Imagine Ice Age hunters relying on proto-dogs to track mammoths, or bands of Homo sapiens sharing warmth with canines during glacial winters. The bond might have even been survival strategy. Some researchers propose that wolves self-domesticated, with the boldest individuals naturally drifting toward human settlements, where scraps were easier than hunting. Over generations, the friendliest survived, passing on traits that eventually gave us the loyal companions we know today. Yet the biggest surprise lies in what these ancient genes reveal about us. Dogs didn't just adapt to humans, we adapted to them. Studies show that regions of the human genome linked to digestion and disease resistance shifted around the same time dogs entered the picture, suggesting their presence altered our diets and exposed us to new pathogens. It's a two-way street of evolution where both species changed in response to each other. So the next time you look at your dog, remember, their ancestry isn't a straight line from wolf to companion. It's a sprawling 40,000-year epic of trial and error, of multiple chances taken across continents, a story still being written in every wag of a tail and tilt of a head. And if genetics keeps pulling at these threads, who knows what other chapters we'll uncover in the oldest friendship on Earth. The Mediterranean island of Crete holds a secret that rewrites the history books, not in grand temples or golden treasures, but in something far simpler: chipped stones lying forgotten in riverbeds. In 2010, researchers studying ancient rock formations along the island's southern coast stumbled upon an impossible find: crude stone tools buried in geological layers dating back a staggering 130,000 years. That date alone should make your spine tingle, because it means whoever crafted those tools arrived on Crete at least 100,000 years before we thought humans could cross open water. These aren't just old rocks, they're proof that our ancestors were bolder, more capable explorers than we ever imagined. Let's unpack why this is revolutionary. Before Crete, the earliest solid evidence of seafaring came from Australia, where humans reached by boat around 60,000 years ago. The discovery of tools double that age on an island never connected to the mainland by land bridges flips the script entirely. Crete sits over 90 miles from the nearest coast, meaning these early seafarers didn't just wade across shallow waters, they intentionally navigated open seas, a feat requiring planning, coordination, and technology far beyond what we credited to pre-Homo sapiens. The tools themselves tell a story of adaptation. Made from local quartz, they include hand axes and scrapers typical of the Acheulean tradition, a style linked to Homo erectus. This raises a breathtaking possibility. Were our small-brained, thick-browed relatives the first sailors? If so, they achieved what we assumed required modern cognition, building rafts sturdy enough for multi-day voyages, reading currents and stars for direction, perhaps even transporting tools or supplies for survival. The alternative, that an unknown hominin species reached Crete even earlier, is equally thrilling. Either way, the implications are profound. Seafaring wasn't a late-stage human innovation. It was part of our toolkit almost from the beginning. But how did they do it? No boats survive from that era, but experimental archaeology offers clues. Researchers replicating Stone Age raft-building techniques found that even simple log vessels, lashed together with vines, could handle short sea crossings when piloted by skilled crews. Ocean currents around Crete suggest a route from North Africa might have been possible during glacial periods when sea levels were lower. Yet even with favorable conditions, the journey would have been perilous, a gamble that speaks volumes about the desperation or curiosity driving these ancient mariners. The most tantalizing question isn't how they arrived, but why. Were they fleeing climate shifts, pursuing migratory prey, or simply drawn by the horizon's mystery? Whatever the reason, their legacy lingers in Crete's soil, a silent challenge to our assumptions about primal humans. If Homo erectus could conquer the waves, what other forgotten feats of ingenuity lie buried beneath the tides of time? Every storm-scoured beach might hide clues to a history wilder than we've dared to dream. Buried deep in the sun-baked caves of South Africa's northern Cape Province, a thin layer of blackened ash might not look like much to the untrained eye. But when scientists subjected these ancient sediments to microscopic analysis, they uncovered culinary history's Big Bang, the earliest definitive proof that human ancestors weren't just eating raw food, they were mastering the transformative power of fire. Wonderwork Cave's million-year-old hearths, revealed through forensic chemistry, rewrite the story of how cooking shaped our evolution in ways we're only beginning to grasp. The smoking gun, tiny fragments of burned bone and plant material, preserved in sediments dating back 1 million years, 300,000 years older than any previous confirmed evidence of cooking. Using techniques like Fourier transform infrared spectroscopy, researchers identified heat-altered crystals in the ash that could only form under controlled, sustained temperatures. These weren't random wildfires, they were deliberate cooking fires, burning at around 500 degrees Celsius, the perfect range for roasting tubers or searing meat. Even more telling, the distribution of these residues points to repeated use over generations, suggesting fire wasn't just an occasional tool, but a cultural cornerstone passed down through families. What were they cooking? The cave's mineral crusts hold clues. Calcium deposits from heated bones indicate marrow-rich meals, while phytolith's microscopic plant silica revealed traces of nutrient-dense roots and seeds. But the real revolution wasn't just what they ate, but how cooking changed them. Heat breaks down tough fibers and unlocks calories our ancestors couldn't otherwise digest, supercharging energy intake by up to 30%. Some anthropologists argue this caloric windfall turbocharged brain growth, allowing early humans like Homo erectus to develop the larger, more metabolically demanding brains that set us apart from other primates. Here's where it gets even more fascinating. Wonderworks fires weren't just about nutrition, they were social catalysts. Gathering around a fire demands coordination, language, and shared responsibility. The cave's layout, with distinct activity zones, hints at proto-kitchens where tasks like butchering and cooking were divided. Imagine the scene, flickering light casting shadows on the walls as generations passed down the sacred skill of fire tending, children learning which roots roast sweetest, elders recounting stories in the glow. This wasn't just survival, it was the birth of culture itself. Yet the biggest question remains unanswered: who lit that first transformative flame? The timing predates Homo sapiens by nearly 1 million years, pointing to our distant relatives like Homo erectus or even Australopithecus as the original chefs. Without fire-starting tools, they likely nurtured captured wildfire embers for years, a fragile lifeline requiring constant vigilance. One storm, one careless moment, and their precious technology could vanish. That they kept it alive speaks volumes about their ingenuity and grit. So the next time you bite into a grilled steak or roasted vegetable, remember, you're tasting the legacy of an innovation so powerful it reshaped our bodies, brains, and societies. And deep in Wonderworks' quiet chambers, those million-year-old ashes still whisper the secret that made us human, not by the food we ate, but by the fires we learned to keep. The tiny inhabitants of Flores Island just got a new lease on life, or rather, a revised expiration date, when researchers revisited the sediments of Liangbua Cave with cutting-edge dating techniques. They uncovered a truth that sent shockwaves through paleoanthropology. Homo floresiensis, the meter-tall hobbits, didn't vanish in some distant prehistoric twilight. They clung on until a mere 50,000 years ago, walking the jungles of Indonesia at the same time our own ancestors were spreading across the globe. This isn't just a tweak to the timeline, it's a paradigm shift, forcing us to confront the eerie reality that two human species once shared those island mists and only one walked away. The original estimates, based on rudimentary methods in the early 2000s, suggested the hobbits disappeared around 12,000 years ago, but advanced luminescence dating, a technique that measures when mineral grains last saw sunlight, revealed a far more dramatic story. The layers containing Homo floresiensis fossils weren't 12,000 years old. They dated to between 50 and 60,000 years, coinciding almost exactly with the arrival of Homo sapiens in the region. Suddenly, Flores Island became ground zero for one of prehistory's most haunting mysteries. What happened when modern humans met these ancient, diminutive cousins? Evidence from the cave paints a troubling picture. The same sediment layers that hold hobbit bones also contain fragments of charred wood and butchered stegodon remains, proof that these small, resourceful people were thriving right up until the moment they disappear from the fossil record. Then, abruptly, their tools vanish, replaced by distinctly modern human artifacts. It's like flipping a switch. One culture's presence extinguishes another's. The coincidence is impossible to ignore. Did our ancestors bring disease to which the hobbits had no immunity? Was there competition for scarce resources or even outright conflict? Without direct evidence, we're left reading between the lines of dirt and bone. But here's the twist that keeps scientists up at night. 50,000 years ago, Flores wasn't some isolated backwater. It sat at the crossroads of a human migration superhighway, with Homo sapiens Island hopping toward Australia. If hobbits survived here, might pockets have endured elsewhere, hidden in the archipelago's countless caves? The discovery of another small hominin, Homo luzonensis in the Philippines, hints that Flores wasn't unique, just the first domino to fall in a much larger story of coexistence and extinction. What's truly humbling is realizing how fragile the balance was. The hobbits had weathered volcanic eruptions, climate shifts, and predatory giants like Komodo dragons for nearly 1,000,000 years. Yet within a geological blink, perhaps just a few generations, they were gone. Their revised timeline isn't just a scientific correction, it's a memorial for paths not taken, a reminder that evolution's tapestry is woven with threads both resilient and heartbreakingly fragile. And somewhere in the soil of Flores, the answer to prehistory's quietest disappearance still waits to be unearthed. A cracked human tooth might seem like an insignificant relic until you realize it holds the oldest dental filling in history. In a Slovenian cave, archaeologists unearthed a 6,500-year-old mandible with one molar bearing something extraordinary, a beeswax filling carefully packed into a deep cavity. This isn't just a curious artifact, it's a window into Neolithic medicine that proves our ancestors weren't just surviving pain, they were actively treating it with remarkable sophistication. The tooth itself tells a story of suffering and ingenuity. Microscopic analysis revealed vertical fractures radiating from the chewing surface down to the roots, likely caused by grinding tough grains or accidental trauma. The pain must have been excruciating, exposed dentin sensitive to temperature, pressure, even air. But here's the revelation: someone recognized this problem and intervened. The beeswax, applied while still soft and sticky, sealed the fissures like a natural dental composite. What's astonishing isn't just the procedure's existence, but its timing. This predates the earliest known metal dental work by over 4,000 years, proving that long before metallurgy, humans were already engineering solutions to improve quality of life. Why beeswax? Neolithic healers likely understood its antibacterial properties, observed from its use in preserving food or treating wounds. The wax's plasticity made it ideal for molding into cavities, while its natural resins may have soothed inflammation. But the real genius lies in its application. The filling shows signs of being pressed into the tooth shortly before or after death, either as a palliative measure or a post-mortem ritual to heal the individual for the afterlife. Either way, the intention is clear. This was deliberate, informed care, not guesswork. This discovery flips assumptions about prehistoric healthcare upside down. For decades, we imagined Neolithic people enduring toothaches with stoic resignation. Yet here's evidence they actively sought remedies, blending empirical observation with available materials. The filling's precision suggests specialized knowledge, perhaps healers who understood oral anatomy well enough to target decay without damaging surrounding tissue. It's a far cry from the crude drill and pull methods of later antiquity. The broader implications are staggering. If humans were performing dental repairs 6.5 millennia ago, how much medical knowledge has been lost to time? Beeswax fillings require not just technical skill, but a conceptual leap, viewing the body as something that could be modified to alleviate suffering. This mindset, once thought to emerge with early civilizations, clearly took root much earlier. Yet the most haunting question remains unanswered. Who was this ancient dentist, a shaman, an elder with empirical wisdom passed down through generations? Whoever they were, their legacy lingers in that tiny wax seal, a testament to humanity's timeless drive to ease pain, one innovation at a time. And if they could engineer dental solutions with nothing but beeswax and intuition, What other medical breakthroughs have vanished from the archaeological record, leaving no trace but the echoes of healed bones and quieted suffering? The bones buried beneath the ancient settlement of Balathal tell a silent but devastating story, one etched into the very skeleton of a man who lived and died 4,000 years ago in what is now Rajasthan, India. When archaeologists examined these remains, they found something unprecedented: pockmarks eroding the nasal bones, lesions gnawing at the finger and toe joints, even telltale hollowing of the foot bones. These weren't battle scars or accidental injuries, they were the unmistakable fingerprints of leprosy, making this the oldest confirmed case of the disease ever discovered. This single skeleton rewrites the history of one of humanity's most feared illnesses, pushing its origins centuries earlier than we once believed and revealing how deeply intertwined it's been with civilization from the very beginning. What makes the Balathal discovery so groundbreaking isn't just its age, it's the context. This man wasn't cast out or isolated, as later leprosy victims often were. He was buried within the community, his body carefully placed in a pit alongside pottery and other grave goods. That simple detail shatters stereotypes about how ancient societies treated disease. Far from exiling the sick, these early Indians may have cared for them, integrating them into daily life despite visible symptoms. The skeletal analysis tells a poignant tale. This man lived with leprosy for years, long enough for the bacteria to ravage his bones, yet he wasn't abandoned. His remains whisper a radical idea, that 4 millennia ago, compassion sometimes outweighed fear. But the scientific implications run even deeper. By sequencing ancient DNA from the bacteria preserved in these bones, researchers traced the genetic lineage of Mycobacterium leprae, the microbe responsible for leprosy. The strain found at Balathal is ancestral to all modern variants, confirming South Asia as the likely cradle of the disease. This wasn't just a local affliction, it was a ticking time bomb waiting to hitch rides along trade routes and migration paths. Within centuries, it would explode across Eurasia, carried by merchants and armies to Egypt, Rome, and beyond. The timing of this outbreak is chilling. Balathal thrived during the height of the Indus Valley civilization, a period of booming urban centers and long-distance trade. Brick-lined streets connected cities, and goods flowed between Mesopotamia and the subcontinent. Leprosy, it seems, was an unintended byproduct of progress, a shadow following humanity's first steps toward globalization. The disease likely spread through prolonged close contact, flourishing in cramped settlements where people and animals lived shoulder to shoulder. Yet the most haunting question isn't how leprosy spread, but why it evolved in the first place. Some scientists speculate it jumped from armadillos to humans, while others propose water buffalo as the original host. Whatever its source, the bacteria perfected a cruel strategy, multiplying so slowly that victims unknowingly spread it for years before symptoms appeared. By the time nasal collapse or clawed hands marked someone as unclean, they'd already passed it to dozens more. The Balathal skeleton forces us to confront leprosy not as a medieval curse, but as a mirror reflecting our own societal choices. Its scars remind us that every advancement, trade, urbanization, even compassion carries unintended consequences. And hidden in those 4,000-year-old bones lies a warning. The diseases that shape human history aren't just biological. They're woven into the fabric of how we live, who we care for, and the connections we can't afford to sever. The sticky residue clinging to the inner walls of a 6,000-year-old Spanish burial pot might not look like much until you realize it's the earliest known chemical signature of opium in human history. Discovered in a Neolithic cave near Granada, this ancient vessel held more than just food or water. Its porous ceramic preserved traces of morphine and codeine, compounds found only in the latex of Papaver somniferum, the opium poppy. This isn't just a curious artifact, It's a smoking gun proving that humans were deliberately harvesting and consuming psychoactive substances millennia before we ever imagined, rewriting the story of our relationship with altered states of consciousness. What makes this finding so revelatory isn't just the presence of opium, it's the context. The pot was found in a burial site, nestled among grave goods and skeletal remains, suggesting the drug wasn't used recreationally but ritually. Picture this: mourners gathering in the flickering torchlight of a subterranean chamber, passing the vessel as part of funeral rites, perhaps believing its mind-altering properties could bridge the gap between the living and the dead. The opium's sedative effects might have eased grief, while its hallucinogenic qualities could have been interpreted as visions from the spirit world. This wasn't escapism, it was sacred technology, a tool to navigate life's most profound transitions, but the implications stretch far beyond spirituality. The poppy residues identified using gas chromatography and mass spectrometry reveal a sophisticated understanding of botany and chemistry. These Neolithic farmers didn't just stumble upon psychoactive plants. They cultivated them, processed their sticky latex, and likely developed methods to concentrate or preserve their potency. The vessel's design hints at this intentionality. Its narrow neck would have minimized evaporation, keeping the opium's effects consistent. Such precision demolishes the stereotype of prehistoric people as passive foragers. They were active experimenters, manipulating their environment to meet physical and psychological needs. The geographical spread of these findings adds another layer. Similar opium traces appear in contemporary sites across the Western Mediterranean, from Italy to North Africa, suggesting a shared cultural practice, or even early trade networks specialized in mind-altering substances. Archaeologists have found poppy seed capsules carved into bone pendants and depicted in cave art, further evidence that these plants held symbolic weight. This wasn't a fringe activity, it was woven into the fabric of Neolithic life, a thread connecting communities across vast distances. Yet the most provocative question lingers: why opium? Of all the plants available, why did this one capture the Neolithic imagination? The answer might lie in its dual nature. Unlike hallucinogens that induce vivid visions, opium's painkilling and euphoric effects offered relief from the harsh realities of prehistoric life. Broken bones, infected wounds, the existential strain of subsistence living. In a world without modern medicine, its value would have been immeasurable, but its ritual use suggests something deeper, a recognition that altering consciousness could serve not just the body but the soul. This discovery forces us to confront a humbling truth. Humanity's fascination with psychoactive substances isn't a modern failing, it's as old as culture itself. From Neolithic shamans to modern pharmacology, the drive to transcend ordinary experience has shaped our societies for better or worse. And buried in that Spanish cave, a simple clay pot holds the genesis of a story still unfolding, one where chemistry, spirituality, and human curiosity intertwine across 6,000 years of history. Hidden in the porous clay of broken pottery fragments from Croatia's Dalmatian coast lies a clue to one of humanity's most delicious adaptations: the birth of cheese. In 2018, scientists analyzing 7,200-year-old ceramic shards discovered something extraordinary: crusty residues harboring fatty acids found only in fermented dairy. This wasn't just proof of ancient milk use, it was the earliest hard evidence of cheese making, a technological leap that transformed societies and solved a biological puzzle that had plagued early humans for millennia. The magic lies in the chemistry. Using gas chromatography and mass spectrometry, researchers identified two key compounds in the pottery's pores: milk fats and traces of a byproduct created when bacteria convert lactose into lactic acid during fermentation. That second detail is crucial. It's the smoking gun of intentional cheese production, not just accidental souring. Early Balkan farmers weren't just storing milk, they were actively processing it into a shelf-stable, digestible food. Why does this matter? Because these communities lived at the dawn of agriculture, when adults hadn't yet evolved the genetic mutation allowing them to digest raw milk. Without cheese, dairy would have been off limits to most of them. Here's the brilliant workaround. Fermentation breaks down lactose, making cheese tolerable even for the lactose intolerant. The same pottery shards tell us how they did it: perforated vessels that functioned like prehistoric cheese strainers, separating curds from whey. Some shards even bear the rounded imprints of straining cloths, a tactile connection to artisans who 7,000 years ago mastered biotechnology we still rely on today. Picture the scene: farmers milking their newly domesticated sheep or goats, heating the liquid over fires, then adding natural bacteria or rennet from animal stomachs to trigger coagulation. What emerged wasn't just food, it was survival strategy incarnate. But cheese's impact went far beyond nutrition. By unlocking dairy's potential, these Balkan innovators gained a powerhouse resource. Cheese provided concentrated calories for winter, portable protein for travel, and trade goods that could outlast seasons. Some anthropologists argue this innovation fueled population booms, allowing communities to expand into harsher climates where fresh milk spoiled quickly. The pottery itself hints at cheese's cultural weight, found in ritual burial contexts, suggesting it held spiritual significance alongside practical value. What's truly revolutionary is realizing this wasn't a happy accident. The residues appear across multiple sites, showing standardized techniques passed through generations. These weren't random experiments, they were deliberate refinements of a technology that reshaped human biology itself. Over centuries, as cheese became a dietary staple, natural selection favored those with lactase persistence, the ability to digest milk into adulthood. In a way, cheese didn't just adapt to us, we adapted to it, our genes bending to accommodate this culinary breakthrough. The next time you slice into a wheel of aged cheddar or crumble feta over a salad, remember, you're tasting the legacy of Neolithic problem-solving, a 7,000-year-old pact between microbes, milk, and human ingenuity. And somewhere in those Balkan hills, the ghosts of the first cheesemongers might just be smiling, knowing their strainers and vats launched a gastronomic revolution we're still savoring today. In the shadowy recesses of a Borneo cave, archaeologists uncovered a skeleton that would rewrite medical history. A young adult buried 31,000 years ago with a startling feature: a missing left lower leg, its tibia and fibula cleanly severed mid-calf. At first glance, it might resemble an injury or tragic accident, but the truth etched into the bone is far more revolutionary. The remaining stump showed smooth, rounded edges with no signs of infection or ragged fractures, just deliberate healing. This wasn't a wound, it was evidence of the world's oldest known successful amputation, performed a staggering 24,000 years before the advent of agriculture or metal tools. The precision of this ancient surgery defies everything we thought possible for Ice Age hunter-gatherers. Microscopic analysis revealed the bone had regrown concentrically over years, forming a healthy callus that proved the individual survived the procedure long-term. Even more astonishing, the lack of infection markers suggests the surgeon understood wound management, perhaps using medicinal plants or heat sterilization. Compare this to medieval amputations, where mortality rates often exceeded 60% due to sepsis, and the achievement becomes even more staggering. Whoever performed this operation didn't just slice through flesh and bone. They navigated blood vessels, nerves, and muscle with anatomical insight we'd expect from modern medicine. But how did they do it without metal instruments? Experimental archaeologists recreated the procedure using stone tools available at the time, sharpened obsidian blades capable of making cleaner cuts than early metal knives. The real challenge wasn't the amputation itself, but postoperative care. The patient would have required weeks of meticulous wound cleaning, pain management, and protection from predators while immobile. That they pulled this off in a rainforest environment, hot, humid, and crawling with pathogens hints at a sophisticated healthcare system. Perhaps the community pooled knowledge of local anesthetics like betel nut or antimicrobial resins from jungle plants. The social implications are equally profound. This individual lived for years after the amputation, evidenced by wear patterns on their upper leg bones from adapting to one-legged mobility. In a nomadic society where survival depended on physical labor, their survival speaks volumes about communal support. Someone gathered food, carried them during migrations, and protected them from danger. This wasn't just medical skill, it was empathy fossilized in bone, proving that care for the vulnerable is as ancient as humanity itself. What's truly humbling is realizing how much knowledge has been lost. If Stone Age people could execute life-saving surgeries, what other medical breakthroughs existed before written history? The Borneo amputation forces us to confront a radical idea, that compassion and innovation aren't products of civilization, but the very foundations that made civilization possible. And somewhere in that cave's silence lies a question still echoing: how many other medical miracles have we yet to unearth? Imagine trying to survive an Ice Age winter wrapped in crudely draped animal hides, shivering as bitter winds slip through every gap. Now picture the breakthrough that changed everything: a slender bone needle, barely thicker than a twig, with a perfectly drilled eye. Found scattered across Siberia and northern China, these 40,000-year-old artifacts might seem humble, but they represent a fashion revolution that quite literally clothed humanity against extinction. The invention of eyed needles didn't just make sewing easier. It redefined what clothing could be, transforming hides from flapping coverings into tailored, layered garments that sealed in warmth and unlocked the frozen frontiers of the Pleistocene world. The genius of these needles lies in their precision. Carved from mammoth ivory or bird bones, some measure just 3 centimeters long, with eyes so tiny they could only thread sinew or plant fibers as fine as dental floss. Unlike earlier punch-style needles that merely pierced holes, eyed needles allowed for intricate, continuous stitching, a leap in technology akin to swapping a stone axe for a scalpel. Suddenly, seams could be airtight, hems reinforced, and layers cinched snugly around wrists and ankles to block icy drafts. Archaeologists have even found evidence of decorative stitching in some fragments, suggesting that once survival was secured, these Ice Age tailors began experimenting with style, perhaps using colored threads or beadwork to signal identity or status. But the real game changer was insulation. By enabling tailored, multi-layered garments, think fur-lined parkas with tight hoods or adjustable leggings, eyed needles turned clothing into a portable microclimate. This wasn't just about comfort, it was biological necessity. As humans pushed into glacial environments, their tropical origins became a liability. Without the thick body hair of other mammals, they needed a cultural solution to replace what evolution had stripped away. Eyed needles provided that, allowing for garments so effective they mimicked the insulating properties of animal pelts. The proof is in the migration patterns. Sites with needles correlate with human settlements in previously uninhabitable latitudes, like Siberia's -50 degrees C winters. The social ripple effects were equally profound. Unlike stone tools, which could be crafted quickly, sewing demanded hours of labor preparing sinews, scraping hides, stitching with painstaking care. This likely spurred one of humanity's earliest divisions of labor, with specialists emerging as full-time garment makers. Some researchers argue these needles even hint at gendered roles, as burial evidence links them disproportionately to female artisans. But their impact reached further. Finely sewn clothing became a trade commodity, a status symbol, and perhaps even a storytelling canvas with patterns encoding tribal histories or spiritual beliefs. What's astonishing is how little the basic technology has changed. Modern sewing needles are virtually identical in form, just mass-produced in metal rather than bone. That 40,000 years of innovation haven't improved the fundamental design speaks volumes about its perfection. Yet these tiny tools carry a bigger lesson. Sometimes the breakthroughs that truly alter history aren't weapons or monuments, but quiet innovations that reshape how we interact with our environment. Eyed needles didn't just keep humans warm, they stitched together the very fabric of survival, one delicate thread at a time. And buried in the frozen soils of Siberia, they whisper a reminder: civilization wasn't built on brute force alone, but on the patience to pierce bone with precision, and the vision to see a thread's potential to hold the future together. Hidden deep within the border cave of South Africa, a collection of slender wooden sticks tells a sinister story of prehistoric innovation. These 24,000-year-old artifacts, no thicker than a pencil, bear faint but unmistakable residues, traces of ricinoleic acid, a deadly compound found in castor bean. To the untrained eye, they might look like simple kindling, but chemically they're smoking guns, the oldest known poison arrows in human history, revealing a technological leap that transformed hunting and warfare forever. What makes these poisoned projectiles so revolutionary isn't just their age, but the sophistication behind them. The ricin traces cling to the stick's grooves, evidence that early humans didn't just dip arrows in poison as an afterthought. They engineered delivery systems. Microscopic analysis shows the toxin was mixed with animal fats or plant resins to create an adhesive paste, carefully applied to carved channels near the arrowheads. This wasn't haphazard experimentation, it was precision biochemistry, leveraging nature's deadliest chemistry to maximize lethality. A single nick from one of these arrows could deliver enough ricin to paralyze prey within hours, targeting the victim's nervous system with terrifying efficiency. But why poison? For hunter-gatherers stalking large game like buffalo or antelope, the risks were immense. A wounded animal could charge, gore, or flee beyond pursuit, wasting precious calories. Poison tipped the scales. Even a glancing hit would ensure the target eventually collapsed, allowing hunters to track it safely. The border cave findings suggest this wasn't isolated ingenuity. Residues appear across multiple projectiles, hinting at standardized recipes passed through generations. Some sticks even show burn marks, possibly used to activate the toxin's potency, a primitive form of bioweapon optimization. The social implications ripple far beyond hunting. Poison arrows democratized power. Suddenly, a small group, or even a single individual, could take down massive prey or defend against larger rivals without brute strength. This may have reshaped tribal hierarchies, placing value on botanical knowledge rather than physical prowess. The toxin sources add another layer of intrigue. Castor beans grow miles from the cave, suggesting long-distance trade networks or deliberate cultivation. Other contemporaneous sites reveal arrow poisons derived from snake venom or toxic bulbs, each adapted to local ecosystems. Yet the darkest twist lies in the shadows of intergroup conflict. While evidence of prehistoric warfare is scarce, poisoned projectiles would have been devastating weapons against humans too. A single ambush could incapacitate an entire rival band without direct engagement. The psychological terror alone, knowing a scratch could spell slow, agonizing death, might have deterred raids or cemented territorial control. What's haunting is realizing how advanced this technology was for its time. 24,000 years ago, humans hadn't yet domesticated animals or invented pottery, yet they'd unlocked the secrets of chemical warfare. The border cave arrows force us to confront an uncomfortable truth. Innovation isn't always noble. Sometimes progress wears the guise of a silent, sticky toxin, one that forever changed the balance between predator and prey, ally and enemy. And somewhere in those cave sediments, the echoes of that lethal knowledge still linger, waiting to remind us how far back the arms race truly goes. In the quiet darkness of Germany's Swabian Jura caves, archaeologists uncovered something that still echoes across millennia: delicate flutes carved from mammoth ivory and bird bones dating back 40,000 years. These aren't just the oldest musical instruments ever found. They're a window into the minds of our ancestors, proving that even in the grip of the Ice Age, humans weren't just surviving, they were composing symphonies. The most stunning of these, a flute crafted from the radius of a griffon vulture, boasts 5 precisely drilled finger holes. When replicated and played, it produces a haunting pentatonic scale, a melody that would feel strangely familiar to modern ears. How did they craft such precision without metal tools? Imagine the patience required to hollow out a mammoth tusk, split it lengthwise, carve the bore, then reunite the halves with airtight seals of birch tar. Each step demanded not just technical skill, but an intimate understanding of acoustics. These weren't crude noisemakers, they were engineered instruments, fine-tuned to resonate at specific frequencies. The bird-bone flutes reveal even more nuance. Their makers selectively chose hollow wing bones, naturally suited to wind instruments, and adjusted hole placement to alter pitch. This wasn't accidental artistry, it was the birth of musical science, but the real revelation lies in why they made them. In a world of scarce resources where every calorie counted, expending energy on non-utilitarian objects speaks volumes. Music clearly held profound value, perhaps binding groups together through shared ritual or storytelling. Some researchers speculate the flutes accompanied shamanic ceremonies, their tones mimicking animal cries to summon spirits or aid hunts. Others suggest they fostered social cohesion. Imagine campfires where melodies eased tensions or celebrated victories. The caves themselves amplify sound acoustically, hinting at deliberate performance spaces. The geographical spread deepens the mystery. Similar flutes appear in France's Isturitz Cave and Slovenia's Divj Babe, the latter controversially attributed to Neanderthals. If confirmed, this shatters the belief that musicality was unique to Homo sapiens. Could our extinct cousins have also felt the pull of rhythm and melody? The possibility forces us to reconsider the very origins of creativity, not as a human invention, but as an evolutionary inheritance. What's most humbling is realizing how little has changed. Those Ice Age flutes share the same basic principles as a modern concert flute: controlled airflow, finger holes, intentional pitch. The urge to transform breath into art, to communicate emotion beyond words, bridges 40,000 years in an unbroken thread. And somewhere in those German caves, the first notes still linger, whispering that humanity's oldest language wasn't spoken, it was played. 77,000 years ago, deep inside what's now South Africa's Sibudu Cave, early humans weren't just sleeping on the cold, hard ground. They were crafting beds so advanced they'd put some modern camping gear to shame. Archaeologists sifting through layers of compressed sediment made a startling discovery: intricately layered mats made from bundles of giant river reed stems, carefully arranged into thick, cushioned bedding. But what truly shocked researchers wasn't just the presence of these sleeping surfaces. It was the ingenious additives mixed into the layers. Crushed leaves from the Cape laurel tree, a natural insecticide, were woven throughout the reeds, creating the world's first known pest-free sleeping environment. This wasn't just a place to rest. It was a meticulously engineered health safeguard against malaria carrying mosquitoes and biting midges that plagued the region. The construction of these beds reveals a level of planning that rewrites our understanding of Stone Age living. Microscopic analysis shows the reeds were cut in specific seasons when their stems were most flexible, then dried and bundled to maximize comfort. The Cape laurel, leaves rich in carcinogenic compounds lethal to insects but harmless to humans in small doses, were layered at precise intervals, creating a barrier that would have released repellent oils when crushed by body weight. Even more remarkable, these weren't one-off creations. The cave's stratigraphy shows bedding layers renewed every few weeks, with older mats burned periodically, likely for sanitation, and replaced with fresh materials. What's revolutionary about this discovery isn't just the comfort factor, but what it tells us about early humans' grasp of preventative medicine. malaria parasites found in fossilized mosquito remains from the same period confirm the deadly threat these sleepers faced. By creating insect-repellent bedding, they weren't just avoiding itchy bites, they were actively blocking disease vectors millennia before the germ theory of disease. The beds also served multifunctional purposes. Traces of ochre and tool fragments embedded in the layers suggest they doubled as daytime work surfaces, while scorch marks indicate some sections were deliberately heated for warmth during colder months. The social implications are equally profound. Building these beds required cooperative labor. Harvesting reeds, processing leaves, and assembling mats would have demanded group coordination. The standardized thickness of the layers, consistently around 30 centimeters, hints at shared knowledge passed down generations, and the spatial arrangement inside the cave suggests designated sleeping areas, possibly even family units, foreshadowing the concept of private living spaces. But perhaps the most humbling realization is how this innovation echoes across time. The same Cape laurel leaves used at Sibudu remain part of traditional insect-repellent practices in modern South African communities. In a way, these ancient sleepers didn't just invent the first bed, they laid the groundwork for humanity's eternal quest for a safe, comfortable night's rest. And somewhere in those compressed layers of reeds and leaves, we find a truth more resonant than any artifact. The drive to transform a shelter into a home is as old as consciousness itself. Beneath the rolling fields of Scotland's Dee Valley lies a series of 12 pits so precisely arranged they've rewritten the history of timekeeping. Discovered at Warren Field in 2004, these Mesolithic-era hollows form an arc 50 meters long, each pit positioned to mirror the phases of the moon over its 29.5-day cycle. Dating back 10,000 years, 5 millennia before Stonehenge, this isn't just the world's oldest lunar calendar. It's a window into how Ice Age hunter-gatherers transformed their understanding of the cosmos into a practical tool for survival. The genius of Warren Field lies in its simplicity. Each pit corresponds to a specific night in the lunar month, with smaller troughs marking the quarter phases and larger ones signaling the full and new moon. But here's the twist: the entire arc aligns perfectly with the midwinter solstice sunrise, suggesting its creators didn't just track time, they synchronized it with seasonal events critical to their survival. Picture a community gathering at dawn on the year's shortest day, watching the sun's first rays strike the final pit, signaling the start of a new annual cycle. This wasn't abstract astronomy, it was a lifeline dictating when to hunt migrating herds, when to harvest shellfish before tides shifted, even when to expect the salmon runs that sustained them through brutal winters. What's revolutionary is realizing these pits weren't passive markers. Excavations revealed alternating layers of red and dark fill, some packed with burnt stone, others with animal bones, hinting at rituals where each moon phase was physically acknowledged, perhaps by lighting fires or offering sacrifices. The calendar was more than a tool, it was a living tradition, a way to anchor human lives to celestial rhythms. The depth of understanding this required is staggering. These hunter-gatherers had to recognize lunar patterns over decades, account for seasonal drift, and translate that knowledge into a permanent, communal record without writing or formal mathematics. But the real bombshell: similar lunar timekeeping systems emerged independently across the globe, from Wyoming's 11,000-year-old medicine wheel to caves in Indonesia where Paleolithic artists painted successive moon phases. This suggests tracking lunar cycles wasn't a cultural fluke, but a cognitive breakthrough fundamental to human development. The Warren Field calendar forces us to reconsider what primitive truly means. These weren't people simply reacting to nature's whims. They were predictive scientists using dirt and memory to build the first bridges between the earthly and the eternal. And if they could map time 10,000 years ago with nothing but dug holes and observation, what other forgotten systems of knowledge might still lie buried, waiting to reshape our story? The answer whispers in the quiet alignment of those Scottish pits, where moonbeams still touch the same earth as they did when humanity first began to count the nights. In the dusty ruins of Iran's burnt city, archaeologists uncovered a skeleton that would rewrite the history of medical artistry. A woman buried 4,800 years ago with an artificial eye so sophisticated it still stares back across millennia. This wasn't a crude ornament or symbolic offering. It was a functional prosthetic crafted from lightweight bitumen paste mixed with animal fat and overlaid with delicate gold foil to mimic a living iris. Tiny perforations along the edges once held threads to anchor it in place, while microscopic wear patterns reveal it wasn't just a funeral accessory. This woman wore it in life, possibly for decades. The craftsmanship is breathtaking. Weighing barely half an ounce, the eye's convex surface followed the natural curvature of an eyeball, its gold inlays reflecting light like real tissue. But the true genius lies in its medical insight. The interior bore traces of herbal compounds, likely antimicrobials to prevent infection in the empty socket. This was no mere cosmetic trick. It was a biomedical device addressing both form and function. Forensic reconstruction suggests the woman lost her eye in early adulthood, perhaps to trauma or disease, yet her skeleton shows no signs of the social marginalization often inflicted on the visibly disabled in ancient societies. Instead, she was buried with honor, surrounded by fine ceramics and lapis lazuli beads. What's revolutionary isn't just the prosthetic's existence, it's what it reveals about Bronze Age healthcare. Creating such an object required multidisciplinary collaboration. Healers to manage the wound, craftsmen to shape the bitumen, metallurgists to hammer gold foil thinner than a petal. The bitumen itself, sourced from distant natural seeps, hints at trade networks supplying medical materials. This level of specialization demolishes stereotypes of ancient medicine as purely shamanistic or trial and error. These were practitioners with anatomical knowledge, material science expertise, and a commitment to patient dignity that rivals modern prosthetics. The eye's design even accounts for psychological impact. The golden iris wasn't just decorative, it replicated the warm brown tones common in the region, helping the woman blend into her community. Some researchers suggest the slight tilt of its pupil might indicate custom shaping to match her surviving eye. Imagine the skill required, artisans working without magnifying lenses, yet achieving microscopic precision to restore not just vision's absence but identity itself. Yet the greatest mystery lingers in her empty socket. CT scans show bone remodeling consistent with long-term prosthetic use, but also strange markings, grooves that suggest the eye might have been mobile, perhaps connected to remnant muscles. Could this be evidence of the first attempt at kinetic prosthesis? Without the organic components, we'll never know for certain. But the possibility hints at ambitions far beyond what we thought ancient medicine capable of, not just replacing but reanimating. This singular artifact forces us to reconsider the origins of medical technology. 4 millennia before silicone or 3D printing, a civilization we often label prehistoric engineered a solution that addressed pain, infection, social stigma, and self-image in one elegant device. And if they could achieve this with bitumen and gold, what other leaps of healing and ingenuity have been lost to time, waiting beneath some unexcavated dune to astonish us anew? The burnt city's prosthetic eye doesn't just let its owner see, it lets us glimpse an ancient world far more advanced and far more compassionate than we ever imagined. The grimacing patient lies still as the shaman reaches for a gnarled root, not for magic but medicine. Recent discoveries reveal prehistoric humans weren't just enduring surgical pain, they were likely dulling it with nature's own anesthetics. Deep in the caves of Spain's Albuñol region, archaeologists unearthed 5,000-year-old human remains with something extraordinary, traces of the potent alkaloid scopolamine in their dental calculus. This chemical, found in deadly nightshade plants like mandrake, doesn't just induce hallucinations, it paralyzes pain receptors, suggesting these early patients were sedated during procedures like trepanation or tooth extractions. But how did Stone Age healers unlock these properties? Ethnographic records from surviving indigenous cultures provide clues. The Amazon's Matses people still prepare a paste from the venom of giant monkey frogs mixed with tobacco ash, creating a transdermal anesthetic strong enough to numb limbs for hunting rituals. Similarly, prehistoric Europeans may have combined mandrake with alcohol or fats to enhance absorption, as evidenced by residue in ceremonial drinking vessels from Neolithic Germany. These weren't random experiments, they were refined recipes passed down through generations of trial and observation. The real smoking gun comes from Bronze Age Cyprus, where archaeologists found a surgical kit buried alongside dried opium poppy capsules. The positioning wasn't accidental, the pods were crushed in a way that maximizes morphine release, their sticky latex still clinging to stone scalpels. Modern experiments show that applying this paste to wounds reduces pain perception by over 60%, enough to make bone setting or wound cauterization bearable. What's astonishing is the precision of their dosing. Some Neolithic skulls show healed surgical cuts exactly matching the depth that opium's 4-hour window of efficacy would allow. Yet the darkest revelation lies in the risks these early anesthesiologists undertook. Mandrake overdoses cause fatal respiratory depression, while scopolamine-rich nightshades can trigger psychotic breaks. Some burial sites contain skeletons with clenched jaws and twisted limbs, gruesome evidence of miscalculations. But the fact that these practices persisted for millennia, spreading from Europe to the Andes, proves their success rate outweighed the dangers. This redefines our view of prehistoric medicine. These healers weren't just brute force surgeons, they were proto-pharmacologists manipulating neurochemistry with the same ingenuity they applied to flint knapping or fire making. Their legacy lingers in modern operating rooms. The mandrake's tropane alkaloids are still used in scopolamine patches for motion sickness, while opium's derivatives remain gold standard painkillers. The next time you're given anesthesia before surgery, remember, you're part of a tradition stretching back to shamans who looked at a poisonous root and saw not danger but relief, and in doing so tamed suffering itself. Think about where we started this journey, with the assumption that prehistoric humans were simple, uninnovative creatures just struggling to survive. But these 30 breakthroughs paint a radically different picture. A world where our ancestors performed brain surgery, sewed tailored clothing, crafted musical instruments, and even engineered pest-repellent bedding. Each discovery peels back another layer of what we thought we knew, revealing societies as complex, inventive, and adaptable as our own. Take the Lomqui tools, proof that toolmaking predated Homo sapiens by millions of years. Or Göbekli Tepe, showing hunter-gatherers organizing massive construction projects long before agriculture. Then there's the burnt city's prosthetic eye, a marvel of biomedical engineering crafted 4,000 years before the Romans. These aren't isolated anomalies, they're threads in a tapestry of ingenuity stretching back further than we ever imagined. But here's the thrilling part, every answer uncovers new mysteries. The hobbits of Flores Island force us to ask how many other human species thrived in isolation, only to vanish without a trace. The Denisovan DNA in modern humans hints at lost lineages we've yet to unearth. And those million-year-old hearths in Wonderwork Cave challenge us to rethink the very origins of culture itself. The past isn't a static timeline, it's a living puzzle with pieces still missing. This is why archaeology isn't just about digging up artifacts, it's about rediscovering ourselves. Every broken pot, every charred seed, every fingerprint in ancient clay whispers the same truth. Humanity's story is richer, stranger, and more interconnected than textbooks ever let on. And if we've uncovered this much in just the last few decades, imagine what lies ahead. So stay curious. The next groundbreaking discovery might be lurking in a cave, a forgotten burial site, or even a single bone fragment waiting to rewrite history all over again. If you're as fascinated by these ancient mysteries as we are, subscribe now, because the deeper we dig, the more astonishing the past becomes, and who knows, the next revelation could change everything.